Today we're going to be taking a look at cosine function graphs and how they compare to the sine function graph. So our parent cosine function graph comes from the equation y equals cosine of x. We're going to treat it very similar to how we did the sine graph. We're going to take a look at the major points from the unit circle. So starting with our very first point, 0 pi, we know that the cosine of 0 pi is equal to 1. So we can go ahead and plot that point on our graph. The second major point we used for the sine graph was pi over 2, which we know for cosine is equal to 0. The next point is pi, which we know cosine of pi is negative 1, followed by 3 pi over 2, which is another 0 point for the cosine graph. Our final point is 2 pi, which gets us back to 1, completing one whole cycle. Unlike the sine graph, which had 3 x-intercepts, cosine graph only has 2 x-intercepts through the terms from 0 pi all the way up to 2 pi. It has 2 maximum points and 1 minimum point, compared to the sine graph, which has 1 maximum and 1 minimum. But we still use the same 5 major points. So the graph is going to look very similar, however, it's just slightly different. It's shifted almost. So instead of our sine graph starting at 0 and going up to 1, then back to 0, then to negative 1, then ending at 0, cosine graphs start at 1, go to 0, negative 1, 0, and end at 1. In general, our cosine function graph will have a similar equation to the cosine, or to the sine. Instead of it being y equals a sine of bx, we just replace sine with cosine. So y equals a cosine of bx. Everything else remains the same. The amplitude will be the absolute value of a, or the distance from the maximum point to the midline, or the minimum point to the midline. It's the same, because distance is always positive. Our period length is still going to be 2 pi divided by the b value, and it's measuring the distance it takes for us to repeat a cycle, or starting at one point, ending at another point that just restarts all the values all over again. The major points, we're still going to take the period length and divide it by 4, just like we do for the sine graph, and it's the same values as the sine graph. So if we take a look at a change, this time we notice that the function is y equals 2 times the cosine of x. So it's not quite the same as the parent function y equals cosine of x, because we now have a value out front. If we can see on the right there, we have graphed our parent function as a comparison to what's going to happen with that 2. So we take a look at our amplitude, the a value, which in this case is 2. The absolute value, still positive 2. Our period length is 2 pi divided by b. Well, since there is no value on the inside with x, it is remaining 2 pi. Our major points, we take 2 pi divided by 4, which gives us pi over 2. So from our starting point, we're going to just move up by pi over 2 units. So the x-coordinates don't change at all for this equation. The only thing that changes are the couple y value points. So instead of it being 1, 0, negative 1, 0, 1, that amplitude changes it to 2, 0, negative 2, 0, 2. And when we look at our graph, it has now stretched vertically up to 2. So in general, we can say that if the a value is greater than 1, then it's a vertical stretch of the cosine graph. Our second example here, we have y equals negative 3/4 cosine of x. Again, we have an a value out front that we're going to have to take into account. So the amplitude is going to be the absolute value of negative 3/4, which, because we're looking at distance, it's positive, is positive 3/4. Now that negative is going to play a role in a moment. The period length is 2 pi divided by the b value, which again in this example is 1, so it remains 2 pi. The major points, we take 2 pi divided by 4, and we get pi over 2. So we take a look at our values. Our starting point didn't change, and we are still increasing by pi over 2. So the x values don't change. Here is where our negative 3/4 value is going to kick in. Instead of it being 1, 0, negative 1, 0, 1, we're going to take all of those values and multiply it by negative 3/4. So our new values are negative 3/4 or 0.75, 0, 0.75, 0, negative 0.75. And when we graph it, we can see that compared to the red parent function, our graph is now slightly smaller. In fact, we have compressed it, as well as we have flipped it or reflected it across the x-axis. So in general, we can say if the a value is less than 1, meaning a fraction between 0 and 1, we have a compression of the cosine graph. If the a value is negative, we have a reflection across the x-axis, very similar to all of our graphs from Algebra 2. Now, what if we change the b value? What does that do to the graph? So our new equation is y equals cosine of 2x. Our amplitude this time is 1 because there is no number outside of the cosine. So our height is going to remain the same. We're not stretching nor compressing it. Our period length, however, does change because we are taking 2 pi divided by the b value of 2, which gives us a new period length of pi, which means instead of it having to go from 0 to 2 pi to restart the cycle, now we're going to go from 0 to pi and restart the cycle. Which means when we take our major points, we're going to take pi divided by 4, the period length divided by 4. So instead of it increasing by pi over 2 units, we're going to increase it by pi over 4 units. So the x values will change this time. We have 0, pi over 4, pi over 2, 3 pi over 4, and then pi. Our y values do not change because the amplitude remain the same at 1. So it will remain 1, 0, negative 1, 0, and 1. And when we graph it, we can see that it almost looks like we have crunched the graph in a little bit. In fact, we can say in general, if the b value is greater than 1, we have a horizontal compression of the cosine graph. It's like taking a spring and crunching it together. If we have a fractional b value, so in this case y equals cosine of 1/2 x, we're going to have a very similar thing happen, other than instead of a compression, we're going to see it stretch. The amplitude remains 1. Our period length now is taking 2 pi divided by 1/2. Remembering that when we divide by a fraction, we keep change flip. So we're going to take 2 pi times 2 over 1, which will give us 4 pi. Our major points then, taking our period length divided by 4, 4 pi divided by 4 gives us just pi. So all our values are going to increase by pi units. So the x values will go 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, but the y values do not change. 1, 0, negative 1, 0, and 1 remain the same. So when we plot the points, now it looks like we've actually stretched that spring out. And I know on our graph here, it's hard to actually see it because we've only gone from 0 to 2 pi on our graph here, which is only half of our period length. So we only see half of the graph. We don't see a full period. So now I want you to try it. Identify the amplitude, the period, and the major points for the equation y equals 3 times the cosine of 2x. You can use the graph here on the screen to help you answer the question. All right, something that's also included with both sine and cosine graphs, and you're learning that today in the sine graphs, is a thing called a phase shift. So a phase shift, we can almost categorize it as a horizontal shift of the sine and cosine graphs. In order to calculate our phase shift, we're going to use the equation c divided by b, where c is some number that we are subtracting from our bx value inside the parentheses. What's important about a phase shift is it tells us what the starting value of our equation is in order to use it. So if we take a look at our equation here, we have y equals cosine of x minus pi over 2. Our amplitude is 1 because there is no value up front, so therefore it's an assumed 1. Our period length is 2 pi divided by the b value, and since there is no number in front of x, it is going to remain 2 pi. Our major points, we still take the period divided by 4, so 2 pi divided by 4 gives us pi over 2. But now the new step, our phase shift, tells us our new starting point. So we are going to take the c value, which is pi over 2, and divide it by the b value, 1, to get our phase shift, pi over 2. Which means instead of us starting our x values at 0 and going forward, we're going to start it at pi over 2 and move up by a unit of pi over 2. So our new table is going to be pi over 2, pi, 3 pi over 2, 2 pi, and 5 pi over 2. The y values don't change because the amplitude remains 1, so it's still 1, 0, negative 1, 0, and 1. When we graph it, all that we have done is taken the cosine graph and shifted it over to the right by a pi over 2 unit. So in general, if our c value is positive, meaning it's going to be x minus some number in the parenthesis, we are shifting it to the right. If we notice and take a careful look at the blue line there, it should look very familiar. In fact, the blue line is now the same thing as the sine of x graph. The cosine of x minus pi over 2 is the same thing as sine of x. Another phase shift here, we have y equals cosine x plus pi over 4. As you may have guessed from the last example, if we now have x plus a number, instead of shifting to the right, we're going to shift it to the left. So our amplitude still remains 1. Period length, because b is 1, is still going to be 2 pi. When we divide that by 4 to get our major points, we get pi over 2. And now our phase shift, our c value, we do the opposite of what it says. So negative pi over 4 divided by our b value of 1 will give us negative pi over 4 as our starting value. So our table of values, we have negative pi over 4. Going up by a value of pi over 2 will get us to pi over 4, then 3 pi over 4, 5 pi over 4, and ending with 7 pi over 4. The y values don't change, so it goes from 1, 0, negative 1, 0, and back to 1. When we plot it, we can see that we have shifted the graph, the red parent function, to our new blue one, to the left by a pi over 4 unit. Everything else remains the same. So now here are two problems I want you to try for Monday. I want you to calculate the amplitude of each, what the period would be, what are major points, how much we need to add in order to get from the starting point all the way through our 5 points, and finally, what is our phase shift so we can have our starting point, and then graph the function on the graph paper I have provided you. The first equation will be y equals 2 times cosine 2x minus pi over 2. And the second one will be 1/2 cosine 1/3 x plus pi over 4. They will be due Monday at the start of class.